What's up, guys? And this is Coach Loffer, and we're going to go over angle bisectors today. So if we remember back to last week with segment bisectors, what is a bisector? So remember, a bisector is going to split into equal halves. So it's just going to split it in half. So if we now have an angle bisector, now an angle bisector is going to be a ray that divides an angle into two congruent adjacent angles. So adjacent just means next to, and congruent is just a fancy word for equal. So two equal next to angles. So I have ABC, and it tells me that BD is an angle bisector. So BD is right here, and it's splitting my angle into two equal parts. So how we'll see it is we'll see these marks, and however many marks, that will let me know that each is congruent. So here there's each angle has one. So I would know that the measure of angle ABD is congruent to the measure of angle DBC. So our first example, if FH is an angle bisector, so FH is right here, it's splitting our angle in half. And if the measure of EFG is 120, so EFG, I'll mark in blue, I know that is 120 degrees. What is the measure of EFH? So EFH will be just this half. So I had 120. I know with my bisector it's going to split it in two. So I would want to take 120 and divide it by 2, giving me 60. And I now know that 60 will equal the measure of angle EFH. So that one there is just kind of a basic one. We're going to have 3 more. So now it's letting me know that ray BX is the bisector of angle ABC. So if it's not done, we want to draw that picture for us. So I'm just going to draw angle ABC, and I know my bisector is BX. So now lets me know that the measure of ABX, which I'll put in green, is 5x, and the measure of XBC is 3x plus 10. So because of this bisector, I know that both ABX and XBC are going to be equal or congruent to each other. So I know that this green line of the measure of angle ABC is equal to the measure of the red angle, which is XBC. So what I can do is I can take those values of 5x and substitute them in. So I now have 5x equals 3x plus 10. And so now all I'll need to do is solve for x. So 3x or 5x minus 3x is 2x will equal 10. I will then divide by 2. I get x equals 5. But am I looking for x? No. It's asking for the measure of ABC. So I know that if I take the green and red and I were to add them together, that will give me the whole angle. So what I just need to do now is substitute 5 into 5x, and then substitute 5 again into 3x plus 10 and add them together. So I'll have 5 of 5 plus, I'll substitute into the red part, so 3 of 5 plus 10. Well, 5 times 5 is 25. 3 plus 5 is 15 plus 10. So I'm left with 25 plus 25. So I know that with bisectors, they should equal each other. So as I'm solving for ABC, I have 25 and 25. I know both parts or both angles are now equal. So I'm left with 50 degrees. So 50 degrees will equal the measure of ABC. So this one, it was having us solve for the angle bisectors. Now let's look at this next example. Again, there's no picture, so we'll draw our picture based off the information given. So ray BX is the bisector of ABC. So again, just going to draw my angle. I have A, B, C with ray BX being my bisector. So this one, if the measure of ABC is equal to 4x minus 12, so I know the entire angle of ABC is 4x minus 12. And I know the measure of ABX is equal to 24. So ABX is 24 degrees. Find the value of x. Well, right now, I don't know what the overall angle measure is. But because of my bisector rule, I know ABX is going to be the same as XBC. So even though it's not there, I know XBC is also 24 degrees. So like I did on the last problem, I can add both of these together. So I have 24 plus 24 equals 48. I also could just do 24 times 2, since I have two angles, and get 48 as well. So now I know that 48 will equal the same as the measure of ABX, which is listed as 4x minus 12. So now I'm going to solve for x. So we'll add 12. So 48 plus 12 is 60. 60 equals 4x. To get x by itself, I would divide, and I'm left with x equals 15. And our last example. So ray BX is the bisector of ABC. So again, we're going to draw just a quick picture. So I have A, B, C. I have my bisector, BX. So now, if the measure of ABC is 5x plus 18, so I know that ABC is 5x plus 18, and the measure of CBX is 2x plus 12. Find the value of x and the measure of ABC. So I only have one bisector given, but remember with bisectors, this is also the same as the other half. So what I'll do is I'm going to multiply CBX by 2. So I'll have 2 of 2x plus 12, and that will equal the measure of ABC. And we know the measure of ABC is 5x plus 18. So a little bit of algebra. With this 2, I need to distribute it to both parts. So 2 times 2x, 4x. 2 times a positive 12 will be plus 24. and that will still equal 5x plus 18. So now I'm left with variables on both sides. I need to get my x's on one side, my constants on the other. So here I'm going to subtract 4x, and I'll subtract 18 from both sides. So my 4x and 4x cancel. 24 minus 18 leaves me 6. 5x minus 4x leaves me x. 18 minus 18 cancels. So I'm left with 6 equals x. So there's the first part. I found the value of x. And now the last part, I need to find the measure of ABC. So with this 6x, or x equals 6 I found, I'll now take that and plug it into 5x plus 18. So I take 5 instead of x, we'll use 6. I'll add 18. That will equal the measure of ABC. 5 times 6, 30, plus 18. So 30 plus 18 is 48 degrees. So I'm left with the measure of ABC equals 48 degrees. So again, the big thing with bisectors is label the pieces you do have, and then once you have everything labeled, you've drawn a little picture, it will really clear out what you're trying to solve for. So with that, that is angle bisectors.